Hello everyone, so this is my first presentation on the leucine zipper, and I have some photos to go along with it, so I'm going to pull my slide up really quick. Before I start, okay, so here's the first picture. So the leucine zipper is a coiled coil. As you can see in this photo, it consists of 2 alpha helixes with leucine residues and about 7 residue intervals, so every 7th amino acid. Mutations are often completed to evaluate the effect of changing residues in a protein. There's another photo, as you can see. It's every 7 intervals in the DNA. So electrostatic reactions are where a positively charged side chain interacts with a negatively charged side chain. There are 3 different types of electrostatic interactions: the dipole-dipole interactions, the London dispersion reactions, and hydrogen bonds. Electrostatic interactions are forces between nearby atoms and molecules. Like charges will repel one another and opposite charges will attract. Here's another example of the electrostatic interactions with the attractions, and then the second photo is the repulsions. 2 alpha helixes can generally be held together with a disulfide bonds, ionic bonds, hydrophobic interactions, or hydrogen bonding. In this case, it is the hydrophobic interactions between the leucine molecules and the electrostatic interactions between lysine and glutamate. The principle behind the hydrophobic interaction is that it increases the stability of the complex when hydrophobic amino acids are well protected from the surrounding aqueous media, and hence, as a result, hydrophobic reactions come together, or hydrophobic molecules will come together. The principle behind the electrostatic interaction here is that the opposite charges attract. A residue that could replace leucine, maintaining the stability of the core isoleucine, as it is equally hydrophobic as the leucine with the same chain length and molecular mass. Any hydrophobic residue could destabilize the core by breaking the hydrophobic interactions present. As the surrounding medium is aqueous, the hydrophilic amino acids would prefer to be exposed to the medium rather than being all clubbed to each other. Hence, serine, threonine, aspartate, etc. can destabilize the core. As you can see, for different types of amino acids whose side chains could interact in a similar manner to lysine and glutamate, this is the L-aspartate and the L-arginine, so these are similar to the lysine and glutamate interactions. So the side chains of any pair consisting one acidic and one basic amino acid will interact like lysine and glutamate. For example, the aspartate and arginine, as you can see. And then another example is aspartate and histidine. As you can see, the serine is connected on the left side where the hydrogen bonding is. Then there's a second hydrogen bond between the aspartate and the histidine. And that is my presentation. Thank you for listening.